everybody. So I just wanted to go over the rest of the review sheet with you. Just a reminder, this whole front page just has information organized for you. Everything on the right side are all of your proof reasons that you could use in the reasons column. Make sure you know your 5 ways to prove triangles are congruent, your exterior angle theorem. But let's try some of these. So, first of all, if I give you two congruent triangles, make sure you're not looking at the picture, you're looking at the statement up here. The letters match. So, if I'm looking at, we did these two together, but if I'm looking at angle L, since it's the third letter in that triangle, it's the same as angle Z. And when you're writing an angle, make sure you use the angle symbol. All right, and then segment YZ. Again, those are the last two letters, so it's KL. All right. So in the next part here, it says find each value. First of all the angles in a triangle add up to 180. And if you see these markings, it means that those sides are the same. And since you have two congruent sides, it's isosceles. So the angles across from those are also congruent. So that's 2x, which means this is 2x as well. Those are your base angles. All right, so let's set up our equation. 2x plus 2x plus 5x equals 180. If we add these together, we get 9x equals 180. Divide by 9, x equals 20. Make sure you answer the question they're asking. It says find the measure of angle C. That's what that M stands for, measure of angle C. 5x, 5 times 20, is 100 degrees. All right. Over here, since you have 3 congruent angles, that means that you have 3 congruent sides. So if you notice, ST, the one that they're asking you to find, doesn't have any information there. But since all the sides are the same, we can set the two equal that they gave us because they are equal. And then we'll substitute back in, and we should see the same value. All right, now you could subtract 2w from both sides. But since this 4 is negative, if I add 4w to both sides, we won't have to deal with any negatives anymore. So we're left with 8 equals 6w plus 5. Now, if you don't like the equals 8 being on the left side, you can always move it to the right. But either way, we're going to subtract 5 to get w by itself. So we have 3 equals 6w. Now, I know there were a couple questions about this in class. All right, it's not 2. And don't think, oh, I can't do it because there's a decimal. That's okay. Divide by 6. 3 divided by 6 is 1/2 or 0.5. That's okay. So now if I want to find ST, I'm going to plug it into any of these. 2 times 1/2 plus 5. Half of 2 is 1 plus 5 is 6. Over here, same thing. If you wanted to double check, 8 minus 4 times 1/2. Using PEMDAS, half of 4 is 2. 8 minus 2 is 6. So ST is also 6. All right. This one's a little different. All right. Again, you have 3 congruent sides, which means you have 3 congruent angles. So you could do this a couple ways. I would say, all right, well, if there's 180 degrees, why don't we divide by 3 now? Each angle is 60 degrees, right? So I can say 8 minus 10y equals 60. Subtract 8. Negative 10y equals 52. And then divide by negative 10. Y equals negative 5.2. And that's what it asked us to find. Now you might say, we can't have a negative. Your variable can be negative because what would happen is when you substitute in if you went and multiplied negative 10 times negative 5.2, you would get positive 52. And 8 plus 52 is 60. All right, I told you there was another way we could do this as well. That was simplified a bit. But you could have said each angle is 8 minus 10y and then added them and set them equal to 180. You'd end up getting the same thing, just with a few more steps. Okay, so on the next one, it gave us angle P, and we're trying to get way over here to angle S. Again, you want to look at your markings. This is an isosceles triangle, and these double markings over here mean this is also an isosceles triangle, which means the base angles are the same. All right, so if we do 56 and 56, oops, what am I doing? 112, right? And then, so that's what those angles add up to. And since all the angles in a triangle add up to 180, we can then subtract 180 minus 112, and we get 68 for that vertex. Well, what type of angles do we have going on here? Vertex angles, so they're the same. We see that in proofs. So if that's 68 and these are the same, this is 68. All right, so we'll do 68 and 68, or 68 times 2, either way. And then we'll subtract that from 180. So angle S equals 44 degrees. All right. And the last one like this is your exterior angle theorem. Now, you need to memorize this. If I give you this example, you can't say, oh, this angle is such and such because I'm going to subtract 8x minus 60 from 180. You've got to remember that the two interior angles added together equal your exterior angle. Okay? And this always shows up on the regions. So you're going to see it on the LTAs a lot as well. So 8x minus 60, our exterior angle, equals the two interior angles. So now we're just going to solve. Oops. It should be plus 85. So then we'll subtract 2x from both sides. 6x minus 60 equals 90. Add 60 to both sides. Divide by 6. And we get x is 25. Now, go where it tells you what to find, measure of CBA. So follow that path. Oops, one's the wrong way. I'll change the color. CBA. CBA. So the angle that traces out is what we're looking for. All right. Well, if we're looking for that one, we're going to need to figure out the other two. All right. So 2x plus 5, 2 times 25 plus 5 is 55. All right, now, what do all three angles in a triangle add up to? 180. So I'm going to take 55 and 85, add them together. And then if we subtract that from 180, we'll see that this is 40. All right. So we'll do one last question. We'll make it a word problem, and then we'll move into our proofs. So it does help sometimes if you draw a picture. The measure of three angles of a triangle are represented by those things there, those expressions. Find all the angles and classify the triangle. Don't forget to name it based on its angles. All right, so I'm going to draw my triangle. Doesn't have any letters, but that's okay. Y plus 30. 4y plus 30. 10y minus 30. All right, so all the angles in a triangle add up to 180. So we have 4y, 5y, 15y. And then we have 30 and 30 is 60, minus 30 is 30. So if you want, you can combine it there instead of writing them all out, showing the addition, but you can. Subtract 30. 15y equals 150. Divide by 15. So y equals 10. All right, so let's find our angles. So if I plug it in, 10 plus 30 is 40 degrees. There's one of our angles. 4 times 10 is 40, plus 30, 70 degrees. And over here, 10 times 10 is 100 minus 30 is also 70 degrees. So there's two ways you can name this. We can name it based on the angles. They're all acute. So it's an acute triangle. Now, because you have two that are the same, that means you have two sides that are the same. So it's also isosceles. So again, make sure you answer the question. I wanted to know the angles and to classify using the name. All right, time for our 2-column proofs. I'm going to pause the video, or actually I'll leave it on. If you need to pause it at any point, just do that so you can catch up. You don't have to scribble all this down. That's the nice part about having the videos at home. So when we're doing a 2-column proof, you have your statements, things that you're telling me about the picture, and your reasons. And remember, the reasons are the why. Why did you tell me that first statement? The first thing we want to start with, you could start with freebies. Like I immediately see that angle 1 and 2 are vertical. So you could say angle 1 and 2 are congruent because vertical angles are congruent. Or you could wait and do your givens first. Doesn't matter. So T is the midpoint of RS. All right, and RQ is parallel to PS. So our reasons for writing those were they were both given. Okay, so let's get started. T is the midpoint of RS. T is the midpoint of RS. So what does that mean? Look at your picture. T is cutting that in half. So RT is congruent to ST. And why did I say that? Definition of midpoint. If I give you something in the givens, midpoint, bisect, perpendicular, you're going to use it in your reasons column at some point. Okay, so we're done with that one. Now let's move on to parallel. It doesn't say RQ and PS are the same. It says they're parallel. So think about parallel lines. Anytime you have parallel lines and a transversal, let's look at angle R and S, for example. They are both inside the parallel lines and on different sides of the transversal. So they're alternate interior, and we know that they're the same. Q and P are also the same. So you have two options for this proof. You could say R and S are congruent and Q and P are congruent because alternate interior angles are congruent, and not even use the vertical angles. And then you could just say angle, side congruency. Or you could say angle R and S are congruent, say angle 1 and 2 are congruent by vertical angles, and then you could go by angle, side angle. So you have a couple options here. All right. So why don't we just go with angle R is congruent to angle S, And again, if I gave you parallel, you need to use it over here. So when lines are parallel, and then what type of angles are R and S? It might help to look up here. Alternate interior angles are congruent. All right, and we have an angle. We have a set of sides. So again, you could say Q and P and go angle, angle, side. You could say angle 1 and 2. I'm going to do that just so you have another option. Angle 1 is congruent to angle 2, and that's a freebie. Anytime you see it, you can assume this. Angle 1 is congruent to angle 2 because vertical angles are congruent. It's always a freebie. You don't have to have it given to you. You can't assume anything else. I can't say R and Q are the same. I can't say that, the other segments are the same, even though they are. Okay, so triangle PST. We know I'm done because I can prove at least one of my 5 ways. I'm going to go angle, side angle. So PST is congruent to triangle QRT. And the reason we went with angle, side angle. But again, let's make a little note of this. You could have used angle Q is congruent to angle P for the same reason as number 4. And then you could have used angle, angle, side instead. Okay, 2 more proofs. We already did the one on the last page. Gonna get my statements and reasons set up. Sorry if you hear a dog in the background. She's not happy that I'm not playing with her right now. Okay. AD bisects BE. Things got a little shifted, but that's okay. BA is perpendicular to AD, and ED is perpendicular to AD. Three givens this time. All right, so once again, we're trying to prove the triangles are congruent. Let's see what we have. I already see a freebie right here. Don't know if we have to use it yet, but we'll see. So AD bisects BE. So there's that word bisect. That means we're going to use it over here. I'm going to start right away with it. All right, so what's being bisected? BE is being bisected, not AD. It's important that you notice that. Okay, so BC is congruent to EC by definition of bisect. BC is congruent to EC, definition of bisect. And again, I was given that. I used it right here. That one's done. We have a set of sides. Moving on. All right, BA is perpendicular to AD, and so is ED. So what does that mean? We have 2 right angles. And because there's only one angle at A and D, we can just say angle A and angle D are right angles. And why did we know that? What clue up here gave that to us? Right here. If I was given perpendicular, I'm going to say definition of perpendicular. Okay, now since they're both right, we can say angle A is congruent to angle D. And how do we know that? All right angles are congruent. Okay, so now we have a side and an angle in both. I don't have any other givens, so I'm going to have to use my freebie. Angle 1 is congruent to angle 2, just like the last one. If you want to use angle 1 and 2, you need to make sure to write it. Otherwise, you would have to say angle ACB is congruent to angle DCE. The order of the lettering does count. If you mix it up, you get points deducted. So make sure you just put the 1 and 2 clearly in there. All right, because vertical angles are congruent. There's our freebie. So if you look at the order now, why are the two triangles congruent? By angle, angle side. So triangle ABC is congruent to triangle DEC by angle, angle side. All right, last example. Now, I want to point out, and I did see this a little bit on the quiz, we obviously know that at C, there's two right angles, but it does not give us that, so you cannot assume that. You can only go by what they give us in any freebies. And the only freebie I see shared between our two triangles is this side. AC is congruent to itself, so we do have a freebie. Now, the other thing I want to point out, your proof this time is not proving the triangles, it's proving that BC is congruent to DC. So those are parts. If you want to prove parts, you're going to use corresponding parts of congruent triangles are congruent. CPCTC, that's going to be your very last statement and reason. But before you use that, you need to prove that two triangles are congruent. Again, it stands for corresponding or matching parts of congruent triangles are congruent. So we'll have to first prove that the triangles are congruent. All right, so let's get started. Statements, reasons. Again, I see my freebie. I could write that right away if you want, but I always write the givens first. Totally up to you. I'm going to write the givens first just because that's what I've been doing along with you. So I have a feeling most of you are doing it this way. So get your givens down. Again, if you need to pause the video at any point, just do that. It's not like in class where you have to keep up. All right, so AB is congruent to AD. Nice. So we have a side. And we'll have a couple options. We'll deal with that in a minute. The other thing, AC bisects angle BAD. So first of all, bisects is a statement. It's a given. So I am going to use definition of bisect as my reason. Now, what is being bisected? Angle BAD. So let's follow the path. BAD, this guy up here. So what you need to do, if an angle is being cut in half, this side of your angle is the same as this side of your angle. And again, make sure you put the 1 and 2 in or you can't use it. So I'm going to say angle 1 is congruent to angle 2 by definition of bisect. They could have said, side BD was bisected, and then you'd have sides down here. And then you'd prove them, your triangle's congruent by side, side, side. But that's not the case. Okay. So if you notice, we actually have a couple options. We have our angle, we have our sides. You could say that this triangle is isosceles and then use angle B and D. Or you could just use, and if you did it that way, you would have angle, side, angle as your proof. Or you could just use your freebie, the reflexive property down this side in the middle, and use side, angle, side, which is what I'm going to do. So AC is congruent to AC. And you might say, well, that's because it's the same, but you need to use your reflexive property. And don't forget, we mark it with an X typically on the paper to show that the side of this triangle is the same as this triangle. And reflexive has an X, but make sure you know that. Okay, so if you look, we've got side, angle, side. So now we can say that the triangles are congruent by side, angle, side, and then we can do our last piece. Okay, so it didn't give us the triangles, so it's totally up to you how you do this. I tend to go in alphabetical order first, so I'm going to say triangle ABC is congruent to triangle. Since I started at A and out to B, I'm going to have to say triangle ADC. And we said they're congruent by side, angle, side, but again, you could have said it's isosceles and then said B and D are the same, which would be prove they're congruent by angle, side, angle. But that's a little bit more work. And I know these are long enough as it is. Okay, so now that you've proved that the two triangles are congruent, the CTC part of that, you can say any of their matching parts are congruent. More specifically, BC is congruent to DC. And the reason, CPCTC, which stands for corresponding parts, because that's what we're proving, parts of a triangle, of congruent triangles are congruent. And again, we had to prove the triangles were congruent first before we could use that. Okay, I think that's it. We already did the other proof in the last video, so you're set. Make sure you study and you're ready for the test on Monday. If you have any questions, feel free to send me a parents or student square or an email. We'll see you Monday. Have a great weekend.